Today we're introducing double angle identities and also solving trig equations by factoring or by creative methods. Okay, so here are double angle identities. Sine 2x is equal to 2 sine x cosine x. Cosine 2x can be one of these three, and we're going to work on deciding which is the best for each situation, okay, which of those three to substitute. And then tangent 2x is equal to 2 tan x over the quantity 1 minus tangent squared x. So use the identities at right to simplify is what they've asked for. Okay. Now simplify could mean several different things. So what I mean here is by getting the double angle to no longer be a double angle. So not sine of 2x, but sine of x, and so forth. So here we have sine 2x. What is that equal to? Well, that's equal to 2 sine x cosine x. So we're going to replace that. Now, this 3 was being multiplied by the sine 2x, so it needs to be multiplied by whatever you replace sine 2x with. That is just 6 minus 6 sine x cosine x. And hey, you have like terms. This is a sine x cosine x term, and this is a sine x cosine x term. So just subtract the numbers. 2 minus 6, negative 4 sine x cosine x. Okay, let's look at the next one. Cosine 2x plus 1. We could replace it with the yellow one, the green one, or the blue one. Okay, but I see here that this is adding 1. So what I thought was, what if we chose the one that's subtracting 1 so that we will only have one term at the end? Substituting any of these would still be correct, but I want to choose one that makes my life easier later, okay? Especially when it gets to solving these equations. So I'm going to replace with the green one. 2 cosine squared x minus 1, and then drop the plus 1. That is 2 cosine squared x. One term, okay? That would make our lives easier if we were solving that in an equation. And now this one we're going to use the identities to substitute in and to factor. Right here we have a cosine 2x, so we need to replace this. But which one are we going to replace with? You want to plug in the yellow one, the green one, or the blue one? Well, let's look at the other term. Right here we looked at 1 and we saw, hey, maybe we should pick the one that's subtracting 1 so we can get rid of that 1. What about this sine x? Maybe we can't get rid of the sine x, but it could help us factor. So we're going to choose the blue one because it has only sine in it, and we want only sine to go with sine so we can hopefully factor. So this would be sine x minus quantity, okay, whatever you replace, you have to distribute this negative. 1 minus 2 sine squared x. Go ahead and distribute right in descending order. Now this looks a little bit more like yesterday's where we were, this is in a quadratic form. So we're going to go ahead and factor now. I need two things that multiply to give me 2 sine squared theta, x. 2 sine x times 1 sine x is really the only options I've got. And then I need a negative one, so one of these ones is negative, one of them is positive. And so I'm going to put negative and positive, and we're going to see if we get this middle term of sine x when we add the check terms. Sine x times negative 1 is negative sine x. 2 sine x times positive 1 is 2 sine x. When you add these, yes, you get sine x, the middle term, so you have factored correctly. The factors are top row times bottom row. So 2 sine x minus 1 times sine x plus 1. Remember, this over here was just our check. All right, let's solve some equations now. Solve for all angles on the interval 0 to 2 pi. First of all, let's combine any like terms that we can. I have a sine 2 theta and a sine 2 theta. I want to get those together, so I'm going to subtract 2 sine 2 theta. And I get root 2 sine theta plus sine 2 theta equals 0. Now we need to replace our double angle identity. Okay. There's only one option for sine. It's 2 sine theta cosine theta. We're using theta because of this equation is using theta. Okay. Can you factor this? Yes. You've got 2 terms and a common factor of sine. Yay! So factor out sine theta. All right, we factored out a sine theta, and now we're going to use the zero product property. Sine theta equals 0. Hey, we've done this several times. That would be 0 and pi on the unit circle. And then we're going to solve this one. Subtract root 2. And then divide by 2. And where is cosine theta equal to negative root 2 over 2? Cosine is negative in the second and third quadrants, negative root 2 over 2, so that would be at 3 pi fourths and 5 pi fourths. And these are my 4 answers for my equation. All right, now we have cosine 2 theta. And on the other side, we have a sine squared theta. So I'm thinking, let's plug in the cosine double angle identity that involves sine squared and no cosines at all. So that would be cosine 2 theta is equal to 1 minus 2 sine squared theta. Now let's combine like terms. I'm going to add this so that I don't have a negative. And we don't actually have a sine to the 1 term, just squareds. So we can solve this one by taking square roots, kind of like we did yesterday. That would be 1 plus 4 sine squared theta. So we're going to get sine theta by itself. Divide by 4. Sine squared theta is equal to 1 over 4. Square root both sides. Sine theta is equal to plus or minus the square root of 1 over the square root of 4. Oh wait, I guess I didn't have to write that out. That would just be 1/2. Okay, so sine theta is equal to wherever the y value is positive 1/2 or negative 1/2. Positive 1/2, positive 1/2, negative 1/2, negative 1/2. All the pi sixth angles. All right. Continuing on, we have a sine and a cosine. That's it. I cannot turn sine into cosine or cosine into sine unless it's a squared term. Okay, but I noticed that I only have 2 terms. I have the product of 3 sine theta is equal to the product of negative root 3 times cosine theta. If you only have 2 terms, no constants, no extra things after you've combined, and you have a sine and a cosine, I'm going to divide both sides by cosine. Now, you cannot do this in the cases where you're factoring, okay? You cannot do this. I'm going to show you why you can do it here. You have 3 times sine theta over cosine theta equals negative root 3. You can only divide by cosine if it reduces to 1 on one side. If you reduce to 1 on both sides, then you're losing answers to your equation. Okay, you're just straight up dividing out solutions that are solutions. So you cannot do it if it crosses off on both sides. But you see, sine over cosine does not cross off. What is sine over cosine? That's tangent. So sine theta over cosine theta did not go away. It became tangent. It was substituted. Now we're going to divide by 3. Tangent theta is equal to negative root 3 over 3. Wow, so much more convenient. Tangent of theta equals negative root 3 over 3. That would be at 5 pi 6th and at 11 pi 6th. Okay. Here we have how many terms? 0. You can add anything to 0. Okay, so it's not its own term. You have this term and you have this term. Okay, so I have a sine and a cosine and nothing else. I can solve it very similarly to the way we did number 3. I want you to pause the video and try to solve number 4 similarly to the way we did number 3. I'm going to do it on my own and show you the work in a second. Hopefully you rationalized or noticed, hey, that doesn't look quite right, and you get negative root 3. So where is tangent theta equal to negative root 3? That would be at 5 pi thirds and 2 pi thirds. Okay, we're looking at a bit trickier of examples here with numbers 5 and 6. In numbers 3 and 4, we were able to do this cool little dividing thing because sine over cosine is tangent. But it only works, okay, or I would only like you to use it with sine and cosine only when you have 2 terms. So right now we have, what do we have? A cotangent theta, a 1, a 2 cosecant theta, and a 3 cosecant theta. Okay, well at least I have some like terms. I can combine these, right? That will make it a little less complicated. Cotangent theta plus 1 equals cosecant theta. Okay, I cannot turn cotangent into cosecant. I cannot turn cosecant into cotangent unless they are squared versions of themselves, unless this is cotangent squared or cosecant squared. So what do we have to do? We have to square both sides. We squared both sides when we solved radical equations in Algebra 2. So as a little bit of a review, remember if you had something like 2 is equal to square root x plus 3, you would square both sides and then solve from there. Okay, but whenever you squared both sides, you had to check for extraneous values. Not when you were doing other things like dividing by the square root or even square rooting. You don't have to do that. But when you superimpose the square, like you made this up, you decided I'm going to square both sides, then you have to check all of your solutions. And I'm going to show you how to do that after we solve the problem. Okay, so continuing on. Cotangent theta plus 1, quantity squared. You have to expand it. Do not forget this is going to be a trinomial. You cannot apply this little 2 in there, even though it would be convenient. Okay, it follows the pattern of quantity a plus b squared is equal to a squared plus 2ab plus b squared. Cotangent squared theta plus 2 times cotangent times 1 plus the last term squared is 1 is equal to cosecant squared theta. Guess what? cosecant squared theta, we can rewrite that as a cotangent, okay? We could also rewrite this cotangent squared theta as a cosecant, but since we have a cotangent to the 1, that takes precedence. We're going to move everything to be a cotangent. Okay, so I'm going to subtract cosecant squared and then substitute the identity. So you have cotangent squared theta minus cosecant squared theta. Okay, so now let's replace cosecant squared theta is equal to cotangent squared theta plus 1. Again, don't forget to distribute this negative. This is a Pythagorean identity. Go ahead and now we're going to combine like terms. Cotangent squared minus cotangent squared, that's 0. Negative 1 plus 1, that's 0. So we have 2 cotangent theta equals 0. Divide both sides by 2. You get cotangent theta equals 0. Now I prefer to work with sine, cosine, and tangent, so I'm going to replace cotangent with 1 over tangent is equal to 0. So then we're going to flip both sides. You can put the 0 over 1 if you want. Tangent theta is equal to 1 over 0. Oh wait, that's undefined. Where is tangent theta undefined? Tangent is undefined at pi halves and at 3 pi halves. Okay, now, yeah, that would be our answer, but we squared both sides. So we have to check for extraneous solutions, okay? For solutions that crept in but really aren't solutions. Go back to the original equation. Actually, I'm going to use a slightly varied version of the original equation. So what we had before was this equation, and then we combined like terms. So I would rather plug into the combined like terms version where it's just slightly simpler. Another thing I thought about was, why did I move this cosecant over rather than moving the 3 cosecant over? Is because I wanted the cotangent and the cosecant. I didn't want all 3 terms on the same side. So if you have 3 terms like a cotangent, a cosecant, and some number, I would just put 2 on one side and 1 on the other, because you don't want to have to square a trinomial. It's just going to be way too much work. Okay? These are just ways to make it easier for you. You should still get the correct answer if you did it another way. So we're going to plug in our values. The 2 answers we got were pi halves and 3 pi halves. So we're going to check pi halves. Plug in pi halves to theta. What is cotangent of pi halves? Whoa. Okay, so at pi halves, tangent is undefined. What is the reciprocal of undefined? It's 0. What is cosecant of pi halves? Cosecant corresponds with sine. It's the reciprocal function for sine. So let's go to the y value at pi halves. And that's 1. What's the reciprocal of 1? 1. Does 0 plus 1 equal 1? Yes. So pi halves is an actual solution. Let's check 3 pi halves. Plug it in for theta. All right, cotangent of 3 pi halves. So tangent of 3 pi halves is undefined. The reciprocal of undefined is 0. 0 plus 1. Cosecant of 3 pi halves. Cosecant is the reciprocal of sine. So what is the reciprocal of negative 1? Negative 1. Does 0 plus 1 equal -1? No, it does not. 3 pi halves is not a solution. It appears to be a solution because we squared this and added in more solutions than were truly there. So our actual answer is theta equals pi halves. If you circle 3 pi halves as an answer, you're going to get marked off points because 3 pi halves is not an answer to the original equation they gave us. We've got a sine and a cosine, and a pesky little number. So we can't do the cool dividing thing and change it to tangent like we did in examples 3 and 4. We're going to have to square both sides, okay? And it doesn't matter which terms are on what sides before you square them. Again, like I said, it's easier if you have 2 on one side and 1 on the other. So that's what we have. Let's square both sides. So as I expand this binomial, we take the first term and we square it, so that's 1, plus 2 times the first times the second term, so 2 times -1 times negative sine theta, so positive. Plus the second term squared is equal to cosine squared theta. So I'll subtract and write everything in descending order, so starting with my squared terms. Now replace cosine squared theta with its Pythagorean equivalent, 1 minus sine squared theta. Again, don't forget to distribute that negative, which we'll do in our next step, and then combine like terms. Hey, -1 and 1 is 0. Sine squared plus sine squared is 2 sine squared. It's 2 sine theta. Great, we only have 2 terms and they both have a common factor. 2 and sine theta. So 2 sine theta times, so we're going to divide 2 sine theta from each, so sine theta plus 1 equals 0. Use the zero product property. 2 sine theta equals 0 is just sine theta equals 0, which is 0 and pi. And sine theta is plus 1 equals 0, so sine theta equals -1. Subtract 1 on both sides. Where is the y value equal to -1? There's only one spot, and it's right here at 3 pi halves. So it appears as though we have 3 answers, but we decided to square both sides. And so we have to check for extraneous solutions. Now we've got to check. Let's take the original equation. Plug in your values for theta for the check and pause your video, and I'll do it on mine, and then you can check your answers. All right, so I got that 0 was an extraneous solution, so not a solution at all. And the only ones that checked out were pi and 3 pi halves. So our answers are pi and 3 pi halves.